Hello, fellow problem solvers. So they're going to be doing a problem which stumped me in an exam, which had a prize when I was in university. So this is a problem that I just could not solve, and I love it. I think it's an amazing little thing. So I invite you to try it out for a minimum of 10 minutes, ideally 30, not more than an hour. If you'd like to go along with us, give it a go. Just for the next 10 minutes, just come up with ideas. How would you prove that 2 plus the square root of 3 to the power of n, the whole part of that, is odd for every single n? It's like you can try and try and try, but you will not succeed. Maybe you do succeed. How do I know? So I was looking at, okay, for n equals 1, what do I have? I have 2 plus the square root of 3. I know this is greater than 3 and less than 4. And I'm trying to come up with a general maybe rule on how I can do this. Now, if I have a 2, I'll have 4 plus 3 plus 4 times the root of 3. This is going to be less than 7 plus some c. So I'm looking at c over 4, that's greater than the square root of 3. So I'm looking to have c squared less than 16 times 3, which is 48. So that means c is going to equal 6. Okay, so, and this is going to be less than 8 plus c. Now looking at the biggest positive integer which satisfies this. So I'll have 7 plus 4 square roots of 3 is going to be less than 7 plus 6, which is 13, less than 14. Now, I don't know about you, but this did not seem to come up with a pattern for me. I could not figure out what the idea here was. Like, how do I have 13, I have 3. Where are these numbers coming from? At the beginning, I have 1, the sequence 1, 3, 13. They need to have something to do with powers. This is, for example, maybe the next one is what? We have cubes, so we have 8 plus 3 times 4 times the square root of 3 plus 3 times 2 times 3 plus 3 square roots of 3. It's going to have 12 plus 3, that's going to be 15 square roots of 3. Plus, this is 3 times 3 times 2 is 18, plus 8 is 26. What am I going to do here? You know, like, what am I even doing? Maybe I'm multiplying by 3, right? I'm multiplying roughly by 3. I'm going to have a 39. Like, the main question is 15 square roots of 3. It's going to be less than c. C squared is going to be less than 15 is now what? It's 225 times 3, and this is 675. And I think 25 squared is 625, then 26 is going to be, so it's 25 plus 50 plus, oh, you gotta be kidding me, plus 1. So it seems like 26 is what we have here, so it's 26, but that doesn't make any sense. Then the answer would be 26, so I made a mistake anywhere in my calculations. I'm thinking, okay, so c is equal to 26. Then we're going to have, this is greater than 52, 52. Though that seems wrong, let me double check the calculations. So actually there was no mistake in my calculation. I just did not calculate this, which was 676. So c is actually 25. And it's so close to 26. And this thing we had before was so close to 49, which it was actually 1 away from 49, which is 7 squared. This was 1 away from 26 squared. And at the beginning we had what? We had how many square roots of 3? We had what? 2 plus, yeah, we had the square root of, we just had the square root of 3. which when we square it is 1 away from 4. So it's 1 away from 2 squared, 1 away from 7 squared, 1 away from 26 squared. This should have been a hint to me. It wasn't. I did not figure that out. That when we add these two, when we do this, when we take this to the end, we're very, very close to the next even integer, right? This is very, very close to the next even integer. So now the question is, can we prove that? It's very, very close. And the answer is yes, we can. And how do we do it? Well, we know that if we have 2 plus the square root of 3 to the power of n, if you take 2 minus the square root of 3 to the power of n, add these two together, what is going to happen? Well, this is going to be n choose I, the sum of n choose I, 2 to the I, square root of 3 to the n minus I, right? And you care when this is odd. But this thing right here is going to be equal to the sum of, again, n choose I, 2 to the I, square root of 3 to the n minus I, and then -1 to the power of I. From I equals, I think, actually, is it from I equals -I to the power of n minus I think, if we're going from I equals 0 till n, just to be on the safe side. Actually, from I equals 0 and I is equal to 0, 2 to the I is equal to that. Yeah. But anyways, the thing is, now these square roots of 3 cancel out in here. The signs where the square roots of 3 is negative, like we're here, it's positive, where n minus I is going to be odd, we're going to have the square root of 3. But then here we're going to have -1 to the power of n minus I. And then this is going to be odd as well. So it will cancel the square roots of 3. And we will have that this sum is actually an integer, some integer s. Now, what is this equal to? Well, this is going to be a number between, mind you, 2 minus the square root of 3 is between 0 and 1. So that to the n is again between 0 and 1. So this number is going to be s minus something between 0 and 1. Now, the only thing we need to show is that this s is in fact even. And why is it even? Well, the things you're not canceling out, you're just like adding them twice. So s is even. And that really finishes up the problem, right? You've shown that this sum is then even. And then, like, the sum is even, and then this even number, so it's like some 2s, and then 2s minus some epsilon, where epsilon is between 1 and 0, and epsilon is equal to 2 minus the square root of 3 to the power of n. Actually, yeah, it's between 1 and 0, so you know that this number then, the whole part of it is going to be 2s minus 1, and you proved what you needed to prove. This finishes up a cool little trick problem, and as always, thanks for problem solving.